Hey, hi everyone. I'm audible. Please confirm in the chat so that we can start the today's session. Yes or no? Okay. So now let's start the session. I'm audible. Please confirm in the chat. Okay. So let's first of all try to revise little bit our previous session, whatever the thing that we have discussed in our study session. So we have started with our first pipeline discussion, machine learning pipeline discussion. Let me show you here in Microsoft board. Yeah, pipeline. Yes. So in a study class that we have discussed little bit about the machine learning pipeline, how we are getting the data, what are the steps that we are following whenever we are working on the any machine learning projects. After that, we have seen like how to handle the missing data. These are the procedure that we have whenever we are doing the any machine learning project, like understanding the problem statement, getting the data from local system, database, or the client third party API. After that, data cleaning, EDN, visualization, data preprocessing and feature engineering, model building, model training and predicting and deployment. And after that, retraining. If we are getting the like in a training phase we are getting the 90% of the accuracy, or if in the training testing phase if we are getting 70 or like 60% of the accuracy. So in this case what we can do, so in this case we can do the retraining approach, so that we will get the some more accuracy in training as well as in a testing phase. Okay, so these are the method that we have to handle the missing value, like delete the missing value, imputing the missing data with the mid mode median, assigning a new category, predicting the missing value, assign algo which is support vector machine. But it depends on the problem statements and your data set. We cannot say no, whatever the data that we have in the same data in the same project we can apply the same function like mean mode median. No, it depends on your data set, it depends on your problem statement. Again, for handling outliers we have a different function like standard deviation method, IQR method, interquartile range method, percentile capping and standard deviation method. Again, for handling a imbalanced data, let's say if we have a data imbalanced data, so in this case what we can do the oversampling, undersampling and in sample sampling method we can apply, and then we can build a model. So this is the overall like little bit overview that we have for our machine learning pipeline. Okay, we have already discussed in our previous session, so if you want to watch the whole session you can check it out, the feature engineering day 1 session. Okay, now let's try to go through the code little bit and then we can start the today agenda. Okay, so we have started with the understanding about the problem statement and then importing all those data. We are getting little bit about our data set information to check the missing value, duplicate data, data type, statistics of the data, category present in our categorical data and all those things. We have checked each and everything. We have checked our missing value with the visualization as well using the missing go function. After that, we have checked the description of the data. We have explored little bit about our data set, like how many unique data that we have, if we have a duplicate data. So we have drop all the duplicate data as well. Okay, now we have created two features for the categorical data and for the numerical data, because in our data set we have two features, categorical and numerical. Okay, so for this we have created two features, one for the numerical features and second for the categorical features. Okay, then we have check it out the little bit about our data exploration part. So we have added the two columns. First is a total scores. We have calculated the total scores for adding the math score from here, reading scores and writing scores, so that we will get the total scores. First thing. Second thing that we have average. We have calculated the average, so total score divided by 3. Is the live doubt clearing, live doubt solving available? Yes, you can discuss all those doubts. Sayyad here. Okay. Now let's proceed. So we have even created the percentage column to check it out. Let's say whatever the student that we have. So if the student have greater than 95 marks, they will get the outstanding. If the student have greater than 81 marks, they will get the A, and so on. We have created the one features percentage. Okay, now little bit we have completed the data visualization part. Okay, our data is standard deviation or not. We have checked, okay, what are the insights that we are getting from our visualization. So as you can see in this visualization we are getting the insights here. Standard lunch helped the perform well in the exam, like whatever the student that we have. Okay, so if those students are taking the standard food, Okay, as you can see, we have the standard food here, one. So if the students are taking a standard food, it means they are performing well in the exam. If the students are taking free food, it means there is something good in the standard food, okay, and there is something like less in the like a free food. So that's why students are not performing well whenever they are taking the free food. Okay, so as you can see here, I have written the insights, and here you can see in the graph as well, this color, people are performing well, and whatever the standard, they are taking the like good. Okay, so little bit insight that we have get from our previous class. Now as you can see here from this graph, in our data, 51% of the female member that we have and 48% male member that we have in our data set. Gender wise, you can just plot it, pie plot and all. So this is the little bit like a analysis we have completed in our previous session. Even we have checked the outliers in some of the data, like in our average data, in our math score. Okay, so we have checked the outliers as well. So in this session, even we have checked the correlation matrix. So as you can see here, total score is a highly correlated with the reading scores and the writing score. As you can see, the total score is highly correlated with the reading scores and writing scores. So what we can do in this case, whatever the highly correlated, let's say we have a two highly correlated data. So we can drop one correlated data here, because whenever we are taking the same correlation data again and again, we will not get a like better performance in our model. So what we can do, we can drop one correlated data. Okay, going forward I will show you, and after that we have checked the normal distribution and all. Now day 2. So at day 2 we can start with the, first of all we can find out the outliers. Okay, and based on the outliers we can apply a different method to handle a outliers. As you can see, we have seen here, we have a different outliers, handle a outliers method. Let me show you again. Here, standard deviation method, IQR method, percentile capping method, standard deviation method. So these are the method that we have to handle outliers. Okay, so we can apply all those things and then we can check it out our data. Okay, so I hope till here we all are clear, right guys? Let me know in the comment section if anyone have any doubt. Meanwhile, let me check it out the chat. Yes, anyone, any doubt? Please write it down in the chat if anyone have any doubt. Yes, no? Okay, no doubt. Fine. Now, so let's proceed next. Let's start with the normal distribution using a transformation method. So first of all, we will start with the QQ plot. So using the QQ plot, we are going to check, okay, our data, whatever the column that we have, those columns are the normally distributed or not. Okay, so we have defined only, see, I have written all those codes so that we can like manage our times. Okay, that's why I have written this, all those codes, because these are the visualization steps that we are performing, and whenever we are plotting a visualization steps, it's taking lots of time. Okay, so that's why I have written all those codes. Okay, whenever we can create an API, whenever we can work on the dockerization part, okay, then in this case I will do the live class coding. Okay, so don't worry. Now let's proceed. So we have plotted a density plot here using the C1 library. So I have plotted the KD plot. First I am just taking the subplots, two graph I want in a row wise and two graph for the column wise. So I have defined 2 and 2, figure size and figure size that I have defined here. Now I am plotting the KD plot. First I am taking the math score, shadow true, label that I want a math. As you can see the label, as you can see the math that we are getting. Color wise, you can change your color, depends on your things. Now axis, the first graph that I want here. So axis I define 0 and 1. Next graph, whenever I want the next graph, as you can see there 0 and 1. 0 and 1. Again, in the next graph, if I want here graph, I can define the axis 1 and 0. Okay, so whenever you are plotting a multiple graph, you can define the axis as well as you can plot a subplot. Whenever you are plotting a subplot, you can define the axis. Now the alpha wise is totally up to you. You can define or you can ignore. It's totally fine. Now, first for the math score, second for I'm just defining the reading scores, writing scores, and average. And as you can see, this is the output that we have. So here, as you can see, all the output that we have is a normally distributed, normal distribution data that we have, as you can see here. Okay, now we are plotting the box plot. So for this, what I am doing, I'm just importing the SciPy library. It starts from the SciPy library, defining the function qqplot column, whatever the column that we have, I'm just taking all those column, figure size. Then I'm taking the two graph. I want two graphs, so that's why I'm defining the subplot 1 to 1 and second subplot 1 to 2. Okay, now this plot df dot column. I'm just plotting the probability density function. Let me write it down here. Probability density function, and second I'm just defining the qqplot. Okay, qqplot, and the data, whatever the data that we will get as a normal distribution. So this I'm just defining the normal distribution. Okay, now I'm just checking one by one. This is the function that I have created. Okay, no need to write this code again and again. I'm just creating the function. Okay, and then I'm just plotting one by one. So as you can see, this is the graph that we have. This is the normally distributed graph that we have. But one observation you can see out here. Here you can see the -1 to 1 that we have. Can anyone tell me the reason why that we are getting here? -1 to 1. Anyone? Any observation you want to say here? Yes? No? -2 to 2. No? As you can see here, -2 to 2. All those data are normally distributed data that we have. But before -2, as you can see, before -2 and after 2, we have some data. Those data are not a normally distributed. As you can see, these data are getting here and some of the data are getting here. But from -2 to 2, all those data are normally distributed data that we have. But before -2 and after 2, those data are not normally distributed. Even some of the data are outliers, as you can see here. So what we can do in this case, we will try to handle this data. Even for the same math score, in a math score, again you can find it out here. These functions are normally distributed, but as you can see, little bit here and little bit here. In this graph, you will get the better understanding whenever we can plot the QQ plot. So in a QQ plot, again you can see here -2 to 2. Data are normally distributed, but after 2 and before 2, see some of the outliers, even those data are not normally distributed. So what we can do, we will try to handle it. If the same data we are going to apply for the model building part, we will get like some different types of prediction and some different types of accuracy. Okay, so for this purpose, first of all, we will handle all those outliers. Okay, if our data are normally distributed, okay, then we can apply the same data for the model building part. Now same for the reading score that we have taken, QQ plot. See, little bit data here, as you can see, and here in a probability density function graph. But in the QQ plot, again -2 to 2 data are good, but after 2 and before -2, some data are not normally distributed, as well as some of the outliers that we have here. Even I have written the insights here. From range -2 to 2, average math score follows the normal distribution, but for the value less than -2 and the value is greater than 2, it doesn't follow the normal distribution. So what we can do, we can handle those data. Okay, now identify the outliers. So I have written the function for loop, enumerate the data, numF, whatever the number data that we have. I have defined the number data columns. Subplot, I have defined 4 data that I want 1 2 3 4 5 6 total. So subplot that I have defined 4 9. Every time it will increment 1, so that I have defined I plus 1. Even you can check it out, the subplot C1 documentation as well, so that you will get a better understanding. See, whenever you face any types of issue now, to understand the code part, just try to check it out the documentation. Somewhere here you will get the documentation. Maximum graph that we have, pair plot. Okay, so how to create a subplot? Let me check it out here. Yes, so yeah, axis wise here he is using the axis, but in our case we are using the subplot and the value where we want a data. Okay, so this is, as you can see in the graph, we have a sum of the outliers in our math score, in our reading score we have a sum of the outliers, in our writing score. Let me open my epic pen so that I will show you in a little better way. Yeah, so here as you can see, here little bit that we have the outliers, again here we have outliers, 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 outliers. In our every numeric value, every numeric column, percentage column, average column, total score column, writing score column, reading score column, and math score column. These are the numerical data that we have. Okay, as you can see here I have defined the numerical num df. So numerical function that we have defined here. So in our every numerical function we have a sum of the outliers. Okay, now next we have checked for the same data as a PDF, probability distribution data. Okay, so distribution of the numerical features, subtitle we have defined, font size, this is the like title, this title that I have defined. After that I have defined the numerical features. What are the numerical features that we have? So let me call this function here so that you will get the little bit better understanding. So see here we have all those numerical data, math score, reading score, writing scores, total scores, percentage, average and percentage. So here we have defined the numerical data. We are just calling the numerical features from our data. Okay, data not equal to object. Object it means string. Okay, now we are just calling the range function. Length of numeric features, just first check the length, how many numeric features that we have, and then he can plot the graph. So as you can see here we want total 6 graph. We have defined the 3 graph that we want in one row, and it will increment by 1. Whenever we want a more function, let's say next time I want a 7. So we have already defined 5 plus I plus 1. So what is I? So I it means whatever the data that we have, it will incremented by 1. Okay, now we are using the KD plot x. We have defined the x function, numeric features, color, whatever the color that you want, label wise numeric features, and then we have plot. As you can see here, this is the graph that we have. So this graph, whenever we are checking the first graph, this graph is look like a normally distributed. It's fine, but focus on this graph. Let me little bit up. Yeah, focus on this graph. This graph is, as you can see, little bit, we can say like 80% or 90% of the, we can say okay, this is the graph is normally distributed, but 10% no, little bit. As you can see the far up and down that we have here that we have, this is up and down little bit that we have, but as you can see this is the totally normally distributed graph that we have. Here again you can see the little bit. Okay, so this is the little bit insights that we are getting from here. So we want to handle it, whatever the non-distributed graph that we have. First of all, we can handle those non-distributed graph, and then we can apply the machine learning algorithm. Okay, now let's check the box plot. We are checking with the different. First we have plot the like a normally distributed function. Again we have checked the box plot here. Now we are checking the box plot, whatever the box plot that we have checked here. So we are checking the one by one box plot, same function that we are calling here, one by one in all columns. So here this is the small graph that we have. Here as you can see the four outliers that we are getting here. As you can see 1, let me take the pen, 1, 2, 3 and 1 is 4. But in the below graph you will get the better understanding. This is the average graph that we have. So average, let me check it out. 1, 2, 3, 4 and 1 is more, 5. So this is the like bigger graph that I have created, so that whatever the outliers that we have, you will get all those outliers in your graph. Okay, so that's why I called here this function to get the all the figure size that I have increased, and we are getting the all those box plot. Now next we have created a remove the outliers function. Why? Because anyhow whenever we are going to apply a machine learning algorithm, first of all we can do the all those feature engineering steps, data cleaning, outliers handling, even like if we have a data like imbalanced data, we can handle those things as well. So we have checked, okay, we have some outliers in our data. Now let's try to handle those data. So we are going to apply a IQR method, remove outliers IQR function that I called here, then percentile 25 percentile that I have defined, df dot column quartile that I have defined 25 and 75 percentile. After that I am just printing. Next IQR method that I am going to apply here, percentile 75 minus 25, then upper limit and lower limit that I am going to define. Percentile 75 plus 1.5 into IQR method, and same for upper limit and lower limit. Now I am going to call a where function, np.where df1. What is df1? Whatever the data that we have copied. Right now we are, whatever the function that we are applying now, we are working on the df1. Later part I will show you the skewness part, like before the feature engineering skewness of the data and after feature engineering skewness of the data. Okay, so that's why I have copied the data. So df1, it means this is the data that we have, column greater than upper function. Okay, then again I am defined for the lower function. First is the upper function, I am going to apply on the upper function, and then lower function. Then I am just returning the upper limit function. Now here as you can see, I am just defining the removing outliers method. I hope this code is clear to everyone. Let me know in the comment section if anyone have any doubt in this function. Yes guys, let me know in the comment section if anyone have any doubt in this function. Yes, no? Write it down in the chat guys if anyone have any doubt in this function. Yes, no? No doubt. Okay, now let's proceed. So we have called this function, same function here. I'm going to apply on all those numeric data, whatever the numeric data that we have here, like percentage, average, total score, writing scores, reading scores, and math scores. So I'm going to apply on every function. So here first on the math score, percentile 57, 75 percentile that we are getting 77, upper limit 107 and lower limit 27 that I am getting. Now I am going to define a comparison plot. I want a comparison between all those graphs. Okay, before the removing the outliers and after removing the outliers. So that's why I just call the comparison function df1. Figure size I am going to take one by one all those data. So as you can see the figure subplot that I have defined. Okay, so first math score. In the math score as you can see, first I have defined before the outliers, removing the outliers. So first I have defined the main data and the copy data. df, it means this is the original data that we have, and df1, it means after removing the outliers. So this graph, whatever the first graph that you are getting now, this is the before handling outliers and before removing the outliers. Okay, and this is the after removing the outliers. So as you can see now the graph, as you can see here, 0 outliers that we have in our data, right? Here data is normally distributed that we have. So now our graph math score data is looks good. Now we can proceed next. Why we take df1 copy? Because I want to work on our this, let's say we have some data. I'm just defining a equal to 20 plus 30, 20 plus 30 a. So data that I am getting 50. Now I am going to apply b equal to a dot copy. So the same data I am just copying in b. I want to apply whatever the feature engineering data cleaning step that I am doing, I want to apply on this data, so that the later part I can show you, okay, what is the benefit that we have after doing the data cleaning, after doing the feature engineering like outliers handling and all. So I can compare with this data and this data. I'm not doing anything in our original data. I'm just doing in this data, whatever the data that I have copied. Okay. So for the future, if you want to check the comparison between your original data and working data, then in this case you can just copy your data and then you can do the analysis. Okay. There is no like a coding part or the like benefit that we will get, but yeah, little bit inside that you will get okay, whatever the benefit that you are getting after doing all those steps, you can just comparison between the original data and all those steps, whatever the step that you are doing with those data. Okay, nothing else powerful. Okay, the both the data that we are getting the same data. Okay, copy function we can define the copy function, after that it will work. Okay, we are just copy our data somewhere. Let me show you df1. Yeah, as you can see here, I am just defining the df.copy. Okay, so I am just copy our same df data in our df1 so that we can do the analysis on our df1 data, not in our original data. So later part, whenever you want to check it out, the comparison between df1 and df, you can just check it out, nothing else. So here, as you can see the graph, we have handled the outliers in our math score. Let me check it out for the IQR, removing the outliers IQR. Percentile 25, percentile 59 that we are getting. Percentile 75 we are getting 79. It looks good now. Upper limit 109, lower limit 29. Now same for the reading scores. Before the handling the outliers, these are the outliers that we have. And after handling the outliers, we are getting this graph. Now this is the like a normally distributed that we have. The graph, even you can check it out, this box plot as well. Okay. Same for the writing scores. Before the outliers handling and after the outliers handling. Okay, this is the IQR score that we have. 175 for percentile, 25 percentile, 70 percentile that we have 233, upper limit 320 and the lower limit 88. Okay, now the comparison between the total scores, same thing that we are getting. Now this part, focus on here guys. Before doing the analysis and feature engineering, this is the skewness of the data that we have, and after applying the feature engineering steps, this is the skewness of the data that we have. First, the math score skewness that we have minus 0.27. Now you can check it out, the score of the math score. Now you are getting the difference between df and df1 per full. Yes guys, write it down in the comment. Now you are getting the difference between skewness like df and df1. This is the original data that we have. df is the original data that we have. df1 is the copy data that we have. Whatever the analysis we have completed, we are doing on this data. Now as you can see, the skewness are reduced after removing the outliers using the IQR method, right? Yes, so you can just compare with the original data skewness and analysis data. After applying the feature engineering steps, these are the skewness value that we have. So it's better than original data. Okay, okay, fine. Now let's proceed on the model building part. We have completed data cleaning, let me write it down here. Completed part. First, data cleaning. Second part that we have completed, data analysis and data visualization. Third part, feature engineering, where we have covered remove outliers using IQR method. Now the next part that we have, model building part. So let me check it out, our data df dot head. So this is the data that we have, right? Let me write it down here. 5, not 5, because this is the 5 data that we have 2. So and let me check it out, one more function, df.shape. Why I am just checking? As you can see, the 10 features that we have: percentage, average, writing scores, reading scores, math scores, test preparation, lunch, preventer level of education, race, gender. So what I can do, first of all, we can drop the unnecessary column. So here somewhere that we have grade. Okay, actually look like I have dropped the, let me run this one, cell again. Okay, so I'm getting grade is not found. Okay, look like I need to rerun my cell. Let me run all those cell again so that I will show you. Okay, we are here now. Let me print. It will show you all those data. Yeah, now as you can see, total 12 column that we have: percentage, grade, average. So grade is an unnecessary column that we have, right? Grade is an unnecessary column that we have. So let me drop the unnecessary column first. So I'm just calling the df.drop function, defining the column, whatever the column that you want to replace. I want to replace permanently, so that I define the in place is equal to true. Let me drop. Now you can check it out. df.shape, df.head, let me check it out. Now as you can see, our grade column is dropped. Okay, now in a correlation matrix graph, as you can see here, let me show you correlation matrix graph again here. So test total score column is a highly correlated with reading scores and the writing score. So what we can do, we can drop one column from here, whatever the highly correlated. Let's say we have a two highly correlated data, so we can drop one correlated data, highly correlated data. So the same thing that I am applying here. Here as you can see, I am just dropping the highly correlated data, multicollinear data with the average. So total score I am just dropping. So let me run this cell. After that I am just dividing your data in train and trace. So x that I am just calling df.drop column average, axis is equal to 1. Axis 1, it means the column wise I am just checking, and y I am just taking the average data. Okay, so in a x I am just dropping the average, whatever the apart from the average data that we have, I am just taking for the x, and the y I am just taking the average data. Okay, let me run. Now here I am just calling the numerical feature data. Okay, I'm just calling the numerical feature, d type not equal to object, so it will take the all the data, numerical data. Now as you can see, the math score, reading scores, writing scores, and the percentage score that we are getting. Now I'm just calling the categorical data, so gender, race, parental level of education, lunch, and test preparation course. These are the our categorical data that we have. So I'm just calling the categorical data. I'm just defining, because whatever the categorical data that we have, we can convert the data into the numerical, then we can apply the model building, then we can apply the machine learning algorithm. So for this, first of all, we can convert those data. So that's why I'm just defining the numerical data and categorical data. Okay, both the data, categorical data and numerical data. Now next what I am doing, I'm just splitting our data using the sklearn model. You can just call from sklearn.model selection import train test split, from sklearn matrix import mean square error and R2 square error. See, I am not going to cover this part mainly, like what is mean square error, R2 square error, R2 score, one-hot encoding, pipeline, make, like these things I am not going to cover here, because main aim that we have for this class to work on the feature engineering part and build a model. Okay, I will try to create a separate session for this topic, but not now. Now I'm just importing all those library, train test split, mean square error, R2 square, one-hot encoding, power transformer, standard scaler, min max scaler. I will tell you why I have just imported this thing. So first of all, right now focus on the train test split. I want to divide our data into training phase and testing phase. 70% or 80% we can data use for the training phase, and 20% data we can use for the testing phase. Okay, so that's why I'm just calling a train test split. Now I'm using the column transformation here. Why column transformation? So as you can see, I have written the little bit theory. I'm just copy and pasted from the Google. Column transformation is a skeleton class used to create and apply the separate transformation for the numerical data and the categorical data. As you can see, I have defined the scale data and OHE, one hot encoding that I have applied. Why one hot encoding? Because I want to convert all categorical data into the numerical format. Okay, so that's why I define this one. So to create a transformers we need to specify the transformer object and pass the list information inside the tuple along with the column. So as you can see, I have defined all those things here. First thing here, I have defined under the transformer scales, standard scalar I am going to apply. Slice, I am just taking all those data, whatever the data that we have. Reminder, passing through data I am defined. If you have any doubt, you can just call transformer scalar library. Just go to here and try to read it out. Best way to practice and best way to learn through the documentation, guys. No one will teach you whatever the thing that you will get here now. No one will teach you these things. Okay, so if you want to revise your concepts, if you want to learn everything in depth, just go through the documentation. Everything that you will get, whatever the question that you have in your mind, you will get cleared here. Okay, so whenever you are just learning machine learning library, just check it out the documentation. Okay, best way to learn through the documentation. Doesn't matter whatever the thing that you are learning. Okay, now column transformation that I am calling everything scalar, standard scalar. Okay, now I am just defining the one hot encoding. What's one hot encoding doing? They are converting the categorical data into the numerical features. Okay, so one hot encoding data that I am covered in which format? So as you can see in our one data, let me show you df dot head. Here we have one data race. Here as you can see we have some like A, B, C, D, E type. So for this I have defined the total 5 features 0, 1, 2, 3, 4, 5, 1 to 4. Okay, now let me run this thing. Okay, so column transformer is not defined, so I look like I need to run this one first. Now I need to run. Okay, so one hot encoding that I am defined is sparse, false and drop first, because it will create a duplicate data. So that's why I defined drop first whenever you can do the encoding. Okay, now I'm going to use 2 machine learning algorithm here. First is a linear regression, second a random forest. First a linear regression, second a random forest. Linear regression, it is find a linear relationship between your dependent data and a independent data. Let's say we have a 2 data. Definitely in a linear regression we have a 2 data like dependent features and independent features. So using a linear regression we can find out the relationship between linear independent data and a dependent data. Okay, now I'm just calling the sklearn.linear model, import the linear regression, rich and lasso data I have imported. But these 2 things you can implement. This is the task that we have. I will tell you later, not now. Okay, after that I have defined the matrix, evaluation matrix for the regression like R square, mean absolute error. Okay, now I'm just splitting our data into the train and test. X train, X test, Y train, Y test. 70% data I'm just taking for the training phase and 30% of the data I'm taking for the testing phase. Random state I'm just defining anything you can define. Doesn't matter 1, 2, 3, you can define 1, 2, 3 anything. After that I'm just calling the pipeline. I'm going to create a pipeline for TNF. What is TNF? I'm just, as you can see here, the one hot encoding technique that I have applied here in a TNF. After that scale that I have defined here, scales. Standard scalar I'm just going to apply on our data. So that's why I'm just apply here standard scalar. Now model, which model that I'm going to use? So I'm going to use a linear regression model. What I can do here, let me copy from here and let me run this one. Okay, look like the issue. Okay, linear regression is not imported, so I need to run the before above cell. Okay, now what I can do, I'm going to show you first of all extrain data. Extrain data. So this is the extrain data that we have. Right now let me show you pipe. So this is the function that we have defined here. Column transformer, one out encoding, scale data that we have defined, whatever the thing that we have defined here, it will call here. So we are going to define a pipeline. Okay. After pipeline, what I am doing, I am just fitting up a data, x chain and y chain, calling the predict function where on x data, and then I am just checking the R score and the mean absolute error. So let me check out the accuracy. Now as you can see here, R score that we are getting the 100% and the mean square that we are getting the 5.37. So this is the good model that we have. Can anyone tell me in the chat section? Bro, you are resigned from iNeuron? No. I'm in iNeuron right now. Okay, Himanshu? Okay guys, so can anyone tell me this is the right model that we have? Or we can apply some other model? Yes? Anyone tell me in the chat? Okay, yeah. So what we can do in this case, we can apply linear regression. This is the simple and easy algorithm that we have. Whenever we are studying machine learning, you can start with a linear regression or KNN algorithm. Okay, but whenever we are working on the project, any types of project, we have a different machine learning algorithm. Depends on the problem statement. Like we have a random forest, support vector machine, lasso, regression. After that, we can do the hyperparameter tuning. Okay, so now the score is 100%. Is fine. MAE mean is mean absolute error that we are getting 5.37. But this is not a good model. We can apply a different machine learning model here again. So now what I am doing, again I am just calling the same function, and this time I am defining the random forest regression. Okay, now let me run this shell. Okay, so random forest is not defined, so I need to import a random forest first. Okay, let me run the above shell. Now the random forest is imported, as you can see here. Which step that we are defining in the pipeline? So in the pipeline that we are defining the column transformer, one out encoding, scales, and which model? Random forest regression. Now I'm going to take a prediction. So let's call the extend prediction pipeline and white chain. Let me check it out, the white chain prediction. So this is the prediction that we have, but it's not looks good. Okay, so for this we can check it out what? We can check it out the accuracy. So let's check it out the performance of the training set first. So model training that I have defined here, X chain and Y chain. Let me call this one. And for the X test and Y test. For the training purpose, I define the model R square and MAE. For the test purpose, R square and MAE. Both things. Let me run. Now let's try to check it out the performance of the model before the like a training on the training data and on the testing data. So let me call this one. Now as you can see, the model performance that we are getting on the training data is a 99% and the MAE that we are getting the 0.10 is better than this one, linear regression. Our MAE, mean absolute error, is better than linear regression on the training data as well as on the test data. As you can see, R2 square that we have same 99.90 and here a little bit difference that we have 99.88, but MAE that we have 0.2 and 0.1. So look like we can say okay, this is the good model that we have, but no, we cannot stop here. We can apply a different machine learning model again here, like lasso, regression. Even you can do the hyperparameter tuning as well. Hyperparameter tuning. So these are the methods that you can apply, and then you can check it out your accuracy on test data as well as on the training data. So this is the task that you have. What you can do? You can just change this one. You can just change this function here, random forest to ridge, lasso, support vector machine. Else if you want to do the hyperparameter tuning, then you can change the little bit parameters and then you can check it out your training performance and testing performance. Okay, nothing else, you can just change this parameter. this main algo. Okay, so I hope this project is clear to everyone, right? Syed, Pawful, Himanshu, Rahul, let me know in the comment section if anyone have any doubt till here. Yes, anyone, any doubt till here? Yes, no? If no, then we can proceed next. Okay, that's great. Look like no doubt. So fine guys, this is all about our first agenda or the first week of the agenda. As you can see here, I have written the agenda. Let me show you. Agenda of the first week. So machine learning life cycle discussion. No, this is the study agenda. This one, feature engineering and the model building, including the EDA. Now what next we can do? We can start a machine learning project or a NLP project. What do you want? NLP project, into an NLP project, or into a machine learning project, guys? Write it down in the comment section. First week is completed. Let me write it down here. Completed. Now what you want next? NLP project or a machine learning project? What next? Machine learning project or NLP project? Or shall we start something else, a coding practice? Okay, when you make a stimulate video, okay, so it will be available within a 1 week. Shuman, it will be available within a 1 week. Stimulate end to end with a project. Stimulate video within a 1 week. Or if you want, I will try to cover this one in the live class as well. Now it's totally up to you. Many of you have written the machine learning project, some good project which we can put on resume. Okay, so the resume wise, fine. Okay, fine. Let me check it out some of the project and then I will try to cover it. Okay, machine learning project. Okay, everyone. Even I am going to start like a hacker rank as well as a hacker rank problem solving on live YouTube, Python and SQL. Yes, definitely. Just allow me a second. Let me download this file. And let me put it down on my GitHub so that you can just download it. I'm just uploading on my GitHub so that I can share with you. Actually, I have included everything in day 1 and day 2 here in the same file. So you can use the same file. It's fine. And now let me share with you a code. Yeah, you can download it from here. Let me pin this comment so that you can download it. Okay. Yeah guys, so that's all about the today's session. Most probably tomorrow again I will come on live so that we can discuss some of the data science life cycle Q&A session. Okay, tomorrow I will come up with the Q&A session. Please choose any good project in a humble request. Yeah, sure Shuman, sure. And yeah, tomorrow Q&A session for 1 hour, 7 to 8 PM guys. Okay everyone. Q&A session tomorrow 7 to 8 p.m. Yeah, let me little bit tell me about myself, or let me share my GitHub profile with you guys. Not a GitHub profile, a LinkedIn profile, so that you can connect with me on LinkedIn as well. I know many of you know, but let me share with you. Yeah, this is the LinkedIn profile that I have. Here you can check it out, my experience, each and everything. You can connect with me on my LinkedIn as well. Okay, everyone. This week, most probably on Thursday. Okay, I will try to announce in our this section here in a community group. Just try to subscribe the channel so that you will get a notification. In a community, I will try to announce, Suman. Okay. In a community, you will get a notification. Okay, because if I need to manage my office project as well. Okay. Okay, so fine guys, tomorrow Q&A session at 7 p.m. Okay, 7 p.m. IST. Okay, thank you guys. Thanks for joining. Thank you. Bye bye. See you tomorrow.